So hi, today we are running a cluster over here, but the question is whenever you deploy your workloads, how do you scale them automatically? Do you go and use your device to scale it, like the kubectl apply and all those things, kubectl scale, or how do you do that exactly for your mission critical workloads? So today I have a solution for you, something called KEDA. So it's a cluster autoscaler, and we will use a simple trigger called a CPU autoscaler. So this demo will show you how whenever there is a huge influx of compute for your CPU, you can scale it automatically using the trigger. So for example, if you have a utilization of more than 50%, it will scale your CPU, the pods consuming your resources, like for example, to 2, 3, 4, depending upon your requirement. So we'll see this everything today in this video. But first things first, you should have a cluster. We are using a GK over here, and you should have KEDA installed on your local machine or your local cluster. So we have already done that. You can go to the docs to do that. Next is you need your application, your services, your autoscaler and everything. So I prepared a manifest for that. So let's go and see that. So there are two objects over here, two manifests to be basic. So one is the manifest.yaml, and this contains all your primary deployments. So primary deployments as in it's your deployment with Nginx application with a request of 100 compute units. And what it does is it guarantees that 100 compute units of your CPU is being given to Nginx. The next thing which is more important is the scaled object. So this defines the specific logic about your auto scaling. So whenever there is more than 50% utilization of your CPU, it will go and trigger the autoscaler and the kind scaled objects to maximum replica of 5, depending upon how much CPU you are consuming. And all those things work together, but how do you scale and attack your deployment so that to replicate the real world scenario? It's very simple. You use a load balancer to expose it to the world, and whenever there is traffic coming to the load balancer, it's directed to your deployment to the pod. And if there is a lot of traffic, there is a lot of requests, and then your CPU is being increased. So once your CPU is being increased, this will trigger the scaled object, and it will do the following logic. So let's deploy all those things. So as you see, the deployment has been done, the scale object has been done, service has been done. So let's see all the objects which has been deployed right now. Uh, so as you see, there's a deployment which has a replica set, which has the pod. All those are running. Then there is a service which we have created, but it will take some time to get the external IP over here because we are using a load balancer. So with the load balancer IP, anyone across the internet can access it. And then there is a horizontal pod scaler which we have defined with the minimum pods, maximum pods, and the target CPU composition and conditions. So let's get the external IP for this, and we will use this IP to attack the following deployment. So right now we have the following IP, and if we want to attack, we can just use curl, and as you see, it's just validating and getting the Nginx. But how do we see if the attack has been done on that pod or not? And to check the request, you can get the pods over here, and we can stream the logs to our terminal. So let's do that. So as you see, there is one Nginx, like one curl that went. If we do one more curl, it will show you again the same thing, but there is one more entry over here. But we need to automate this thing because we can't just go on clicking over here to go to the 50% utilization mark, right? So how do we do that? We create a load chain. So if we want to see the load chain, it's basically um, a simple pod called busybox, and we are guaranteeing requests for that, so that it's for sure getting that much request to keep on attacking our IP. And it's just running a simple shell command. What we need to do is we need to replace the IP to the one which we have, not this. Let's open a new terminal. So we will put the new IP over here because we need to attack that entry point. And let's apply the load gen manifest to your host, and the deployment has been created. So now if we check the logs, we'll see there are more requests coming over here, and it's just coming because we have created an automated way to test that. But if we check the how much CPU has been used, you will see it's not a lot, because we can take in more. So how do we do that? It's a simple deployment object. You can scale your deployments. So now with that, we will scale our deployment so that there is more service endpoints being attacked through our load gen application. So let's do that. And the deployment has been scaled. Now if we check the pod, it's increased than previous, and this deployment is being scaled, warmed up and everything. So if we check it again, you will see all of those threes are working hard to send in more requests. So in some time what will happen is we will see that this will increase to a lot more. As you see, there is a new my app being created right now, which is handling the rest of the traffic. So if we go around deep in the events to see what is happening, so you will see a couple of things. First is as you see over here, the replica set has been started to scale from 1 to 2 because HPA told there is more resource utilization than request, and those has been created and scheduled. So as the requests increase, your pods are created and scheduled, and that's the beauty of KEDA. You don't need to do it manually. According to your load or another different triggers, it can be done automatically. So now if we see the number of pods over here, two pods are handling all those traffic. So thanks for watching this video, and I hope you learned something new over here. And don't forget to subscribe and follow along.